Today we are going to deal with the experiment of losses in pipe. So when we talk about the losses in pipe, so there are two types of losses occurring. One is major and minor. So today, mainly we are going to focusing about the major losses. So when we talk about the major losses, it is due to which are the friction between fluid and pipe surface. So for to studying the major losses, we have one test this particular experimental setup in which first there is one some tank in which the water is stored. Okay, and from this sump tank, the motor is connected through which the water is supplied to again the four different pipes. So this is a bypass valve through which we are going to control the flow rate. Now you can observe this particular from which the pipe is coming from the pump. It is connected to the four pipes. Okay, so this is, we can say this is pipe number one, pipe number two, pipe number three, and pipe of number four. By just observation, we can just say that this is pipe 3 and pipe 4 having the same diameter. Just the difference, what they are made to study the major losses. The material of construction is different. In pipe number 3, the galvanized iron material of construction used, and pipe number 4 is stainless steel material of construction used. So both having the same diameter. So what if the material of construction is changed? So what will be the major losses we can observe through this pipe number 3 and pipe number 4? Okay, now just coming back to the specification, that's which are the pipes that are given. That type diameter of pipe 1 is 1 inch, diameter of pipe 2 is 3 by 4 inch, diameter of pipe number 3 is 1 by 2 inch, and diameter of pipe number 4 is 1 by 2 inch. Okay, so again, and you can just observe at the end, means which are the outlet connection that they are provided, through which the water is going to collected into the measuring tank, and this dimension of the measuring tank is 30 centimeter by 40 centimeter, and also the scale is attached, so we can measure the level in that particular tank. So by measuring the level, we can just calculate the actual flow rate of the system, and the output of this measuring tank is collected to again some tank. So this is one of the recirculation type of the equipment. So now this is about the construction of particular major losses in pipes. Now we are going for the working of the experiment. Yeah, to study the major loss effect, first switch on this equipment, and then for finding out the head losses, which are the losses are taking place, the manometric tappings are provided for each pipes. That is, you can just observe that whenever the fluid is coming through this section, this is our particular inlet and this is outlet. So at the inlet, one tapping is provided, and outlet, one tapping is provided. So all of the four pipes having the distance between inlet and outlet tapping is 100 centimeter, and that inlet tapping is connected to, like you can say that this is for the first pipe. This is at the means the connected to this manometer, which is having this mercury as a manometric fluid. Now this is outlet for the pipeline. Similarly, you can just go for the second pipe. This is for the second pipe, then outlet for the second pipe. Same with the third, and same with the fourth pipe. Okay. Now the first, after switching on this, we need to just open this wall so that we can remove the air bubbles from this one, and then just keep which means we can just off this wall after removing the air bubbles. Now it is ready for measuring the head, which are the pressure head is there. So for finding out, so they are provided total four types small knobs. So for just studying for this particular that pressure head, first just on this knob of first pipe. Okay, and you can just measure the difference for this pipe, first pipe. Okay, and just after measuring this difference, noted that which are the values there, the difference in pressure rate. Okay, so after noting the reading of that manometric head, now close the wall of measuring tank so that we can measure the height for the particular time interval. Means say for 10 mm, how much is time required? So from that we can measure the actual amount of that flow rate, that is Q actual. So after closing this one, closing this wall, you can measure, like you can take any distance. Now it is rising 80 to 90, 100 to 110, like this one. You can measure that one, that how much amount is amount of time is required to fill for 10 mm, and from that just calculate the volume of the tank, and you you can measure from that one Q actual. Okay, that is for the first reading of pipe 1. Now, in the similar fashion, we can go ahead with the pipe 2. So, for measuring the pressure head for the pipe 2, first open the wall of pipe number 2 and then close this wall of pipe number 1, that is output wall, and then you can open the manometric tappings of inlet and outlet of that particular pipe number 2 and close the for pipe number 1, and then again measure the difference. Now you can just observe the deviation, that earlier it was smaller, now it is increasing, right? Now again you can repeat the same process. You can close the wall, and again you can observe the rise in water level in the measuring tank, and again repeat the same process to finding out the volumetric flow rate. Now you can observe again there is rising of water level in measuring tank. So again do the similar process for measuring volumetric flow rate. Now coming back to our test kit. Now we want to just measure for pipe number 3. Open that wall of output wall of pipe number 3, and again close the wall of pipe number 2. You can observe that we are closing the wall of pipe number 2, right? So just again open that manometric tapping for pipe number 3, input and output, and repeat the same procedure for finding out the volumetric flow rate for the given experiment. Now you can measure the rise in water level. So you can measure the rise in water layer for 10 mm, how much amount of time is required. And again, you can see that what we call this deviation in this manometric reading. As the diameter is reducing, the head difference is increasing. Now coming back to pipe number 4, open the wall of pipe number 4, close for pipe number 3, close for pipe number 3, and again just open the manometric tapping for pipe number 4, and you can just measure the deviation. Okay, that you can observe that for pipe number 3 and pipe number 4, and you can again just closing this wall, again you can close this wall, and again just you can measure the how much amount of time required to fill the 10 mm to calculate the Q actual. Okay, the same procedure you need to apply for the now. Means this is for the one reading. You can just vary this wall to measure at different flow rate. Means by using this bypass wall, which are connected bypass section, you can measure this pipe friction at different flow rates.